Okay, I'm just going to start talking. And I've got a microphone, so I'm louder than you. So there we go. Right. So good evening. We met earlier. I'm James. I'm the acting head of the newly formed Lunar Science Office in the Directorate of Human and Robotic Exploration in the European Space Agency. As I mentioned earlier, this is kind of a time of change for us. Many things are happening, new things are beginning, and I wanted just to thank Mahesh, actually, and the organisers of the European Lunar Symposium, who suggested that we do something, kind of a town hall. So the idea is what we would like to do. We try to think of a really wonderful interactive thing to do with all sorts of bells and whistles. And in the end, the best we could think of was I'm going to talk at you for ages. I'm going to try and break it up into segments so that you have a chance to ask questions, give comments, yell, scream, whatever you like. And the idea is to give us an opportunity to tell you what's going on, what's happening in ESA, the things that are being planned, the things we've achieved this year, some of our plans for what's coming, some of the opportunities that we would see for you to work with us, so we can work together to do some wonderful things. Chance for you to tell us what you think, to ask questions, to give some comments. I know that you and we have been involved in a number of activities together over the last years, and some of those things I think have worked out marvelously. Some of those things perhaps there's room for improvement. Some of those things perhaps are still open and we haven't succeeded in closing them out yet, and there's some uncertainty about what the future holds. And I think hopefully we can use this next sort of maybe an hour. It could be done much quicker if nobody wants to say anything. If there's things you'd like to say, then this could take a lot longer. At some point, booze will appear. We sponsored the event, and I'm told that the catering is what we did. So all of that excessive quantity of booze and drink that's turning up later on is apparently on us. You're welcome. Right. Right. There you go. So now you have to be nice to us, right? So food and drink all on us, right? Okay. You saw this earlier on. Our space exploration program is called Terra Novae, or New Worlds. That is the amalgamation of what historically is formerly known as the European Exploration Envelope Program. It's called the European Exploration Envelope Program because it is an envelope that contains a lot of different pieces. And historically, these were separate programs where we're an optional program. So our member states get to choose whether they want to participate or not. The science program in ESA is a mandatory program, which means that every single country that participates in the European Space Agency is obliged to pay into that program. And that creates a certain programmatic framework that allows that program to operate in a certain way, with a certain security and a certain planning horizon and other ways that they can work. The exploration program is optional, which means every 3 years, all of our member states get to choose whether or not they'd like to participate, and if so, how much money they'd like to put in. And they get to say something about kind of where their priorities are in terms of where that money goes. There are more than 22 countries involved now. This is a very complicated scenario to try and get 22 countries to all agree to do the same thing every 3 years and to put their money into the program in a way that makes everybody happy. It's not a simple thing to do. But we manage. And one of the things I think that we can be extremely proud of within Europe and within the European Space Agency is that we get 20 plus countries with different funding cycles and different governments and different priorities to work together to do extraordinary things in space. Nobody else does that. That's really something that's completely unique. And so when we talk about international cooperation, international partnership, like there isn't an organization in the world that does that like ESA. And that's something that I'm personally extremely proud of. And one of the wonderful things I find about working within ESA is to work in that environment where we have all this really tremendous diversity of culture and of language and of approaches that we bring to this. So that's the context in which I'm speaking. And what I wanted to talk about a bit is what the program looks like now, and a bit of what the prospects are for the future. So this is what is I guess referred to here as the master plan. This is what we have going on right now. Now, the European Exploration Envelope Program, or Terra Novae, includes 3 destinations. So there is low Earth orbit and everything that humans do in low Earth orbit. There's the moon and everything that goes on around and on the moon, and then Mars. And this is all brought together into a single integrated program, which includes the human spaceflight, robotic missions, and scientific activities. And so in low Earth orbit now, we have the International Space Station, which is the core of our human space flight program in low Earth orbit. And now we're looking to transitioning from that towards the commercial stations that are going to come in the post-ISS world, which will be coming not many years from now. As we move on to the moon, we have the Orion capsule. So at the back end of Orion, you'll see the European service module. That's the power, the propulsion systems, the life support systems. That will go to the gateway. You heard about that from Laurie this morning as well from NASA, where ESA is a major partner and contributor to the gateway. We'll talk a bit more about that a little bit later. And then going down onto the surface, we're now investing in the Argonaut logistics lander, which will take, at least in its first model, around 1.5 tons of payload to the lunar surface with each mission. We'll talk more about that a little bit later. And then Moonlight is a communications navigation network, which is being developed to provide communication navigation services in and around the moon. And an important element of that is that the things that we're doing on the moon now and preparing on the moon now are intended to provide us with the information, with the capabilities, the lessons that will help us to move onwards to Mars. And I'll talk a bit more about what that might look like in a few minutes. And of course, we have the Mars program, where we have Trace Gas Orbiter that's operating at the moment. We have the Earth Return Orbiter as a contribution to the Mars Sample Return mission. We have the Rosalind Franklin rover, which is the what's come out of what was ExoMars, which is planned for now for 2028. The sample transfer arm to move the samples from MSR onto the ascender, and the entry descending landing module, which is the lander that will take Rosalind Franklin down to the surface of Mars. So this is what we have in our program today. This is what our program looks like financially in E3P period 3. So each period, every 3 years, we have a new funding cycle. So every 3 years, we go to the Council of Ministers as ESA with a proposal for what we would like to do. And that is the occasion when all of our member states decide what they would like to put their money into, and we put a new program together for the whole agency. And one of the programs within that is the Exploration Envelope program, now called Terra Novae. And we are in the 3rd period of Terra Novae. So that is a 2.84 billion euro program in this 3-year cycle. We may not spend all of that money within the 3 years, but in that particular block of money is 2.84 billion euros. Of that, we have 10.2%, which is for lunar robotic exploration, primarily on the Argonaut development, but also some payloads and science activities too. And we have the humans beyond low Earth orbit, which includes our contributions to Gateway. At SciSpace, maybe just to point out, SciSpace here is the scientific program that sits within the exploration program, and that primarily addresses the activities that take place in low Earth orbit and on ground-based facilities. At the moment, the lunar scientific activities you'll see are not covered under that, but this is the way it's been set up to date. Okay, so the big effort in the last sort of year or so has been to, if I can show you, there we go, right, to start preparing something called Explore 2040. So Explore 2040 is about us refining and extending the strategy for ESA and exploration in ESA as a part of a refined European strategy, which includes what ESA does and its member states. So something I mentioned earlier is that we are an agency of our members, and so we are there to work with our member states to help implement a European program of space exploration, providing contributions where there is benefit in doing things together rather than on a national basis. So we've been working with our member states over the last sort of year or so to prepare this. And this sits as part of a bigger strategic planning for ESA to take ESA through to 2040. So some of the characteristics of this strategy are firstly to uplift science. So this is something that has been emphasized in our highest levels of management, that science within our program needs to be something which is made bigger, more prominent, and it becomes more impactful. Increasing our socioeconomic impact on Earth, being able to demonstrate that, is also something that's been considered very important. And when we think about how we do exploration, some key words would be, we make sure it's sustained. This is something that we continue to do, that it's sustainable. That sometimes means financially, but I think that more importantly means that we do it in a way which is respectful of the environment and the places that we are going. We do it in a way which is sustainable from an environmental and from a responsible custodianship perspective. And so being responsible in the way that we explore these locations is also something that is considered very important. The characteristics of what we're trying to achieve when we do this, firstly, to be ambitious, to go beyond. So just to give you some idea, the exploration budget for ESA is around 8%, the equivalent budget for the United States. So that's for an economy which is about the same in size as the United States. So that tells you something about the level of ambition, the level of importance that this has from on a political basis, that kind of money that we're talking about. And so what we want to do is to increase our ambition in terms of what we're trying to achieve and the way that we do it. An important element of that is going to be some leadership, that we take the lead in the things that we would like to do, and we call self-determination. So international partnership is always going to be a part of what we do and why we do it. But we would like to move into a scenario where we are more determining our own pathway, where we have less dependency on partnerships, but we are perhaps a stronger partner by being mutually independent within those partnerships. We're able to function in a way where we drive ourselves. We want to be unique. So we want to find the things that we in Europe are really uniquely able to do, where we can really bring benefit or do something that's different from what others are doing, not to copy what others are doing, but to try and leapfrog, to try and find ways of providing benefits or value without copying what others are doing. And finally, to make sure that what we're doing is we create options for ourselves and we identify the synergies between the destinations. What we're doing in low Earth orbit, at the Moon and at Mars, and try and leverage the synergies between those things whenever we can. Give you some idea of what this looks like at a strategic level. If I can, there we go, right. So I realized like earlier on that this screen can be a little bit difficult to see from some places in the room, but the intention is that we maintain a human presence in and utilization of low Earth orbit, that we want to have vehicles that are going to low Earth orbit. So this would include cargo to low Earth orbit and back, and eventually crew activities, have our own ESA ability to, or European ability to get crew to low Earth orbit and back. Going onwards towards the Moon, we have the European service modules for Orion, and you heard a bit about those earlier on also in Laurie's talk. And the idea is to have this sample return vehicle. I mentioned that earlier. There is this need identified to find ways within the overall architecture to get samples back from lunar space, cislunar space. And so we're investigating what a sample return vehicle from Europe might look like. At the Moon, we have the Argonauts as a way of getting down to the surface of the Moon, and we have Gateway as a platform which we have for humans. So Gateway, just in case it wasn't clear, is a human-tended platform in lunar space, which is being developed with our international partners. So we have the Moon-Mars evolution to heavier payloads and precision landing and radioisotopes as a key capability to get us almost to the Moon, from the Moon to Mars. ISRU you'll see as an increasingly prominent element in our program. We talked a bit more about that earlier, about the importance of resources and as an element of the program. We have nuclear propulsion as something for the longer term as we move onwards to Mars, and deep space habitation and the way we might use our activities in deep space, way of de-risking that for the future too. And communications and navigation as being something which is really applicable everywhere, something we would like to do. So this is our refined European exploration strategy. It's something which is in preparation at the moment. It is not finalized. The timeline for the evolution, the finalization of this is we have, this is coming at the Space Summit, would be where this was kicked off in November 2023. So that was a very high political level summit. We have the program board, which is our ESA level programmatic decision making. They were consulted in February of this year. We have the ESA Council, which is in March of 2024. So that was very recently. And then the ESA 2040 strategy is when that will get finalized. And we're hoping to have a public version of this, codifying in more detail some of the things I've talked about here at some point in pretty soon. So public 2024, June 2024. So I think that we should be expecting that pretty soon. In terms of science in this program, there is, I think, some changes that this is all kind of being discussed at the moment with our member states and with our advisory structure. But I think there are two core pillars which are a little different in the way that we would do them. So the first of these would be exploration for science. So this is the way that, having gone to the Moon, with Argonauts, with Gateway, with other platforms, we can now use the fact that we have access to the surface of the moon to do science that we couldn't do in any other way. And here we've really been pushed to try and emphasize world-class, really high impact science. There's also science for exploration, and this is something which is going to become, I think, increasingly prominent and prioritized within our program, and I'll talk a bit more about that shortly. But this is where the science that we have to do in order to be able to explore. And so the idea is that we are not a science program purely, we are an exploration program. And we need to be doing science that is really applied and useful in the context of preparing and enabling the future of space exploration. So some of this, the way that we do these things might be different. So basically one is pretty much top up, top down, and one is bottom up. So if you think about exploration, what we're calling exploration focused science, this would be science that we need to explore. This is where we as ESA would need to define the knowledge gaps and the scope of the science that we would need to do. And then we need to consult with this. So I should be clear that this is in preparation, it's pre-decisional. So this is something which is in consultation at the moment. The other side would be exploration enabled. So this is science which is enabled by exploration, where we would define with our partners what, or with the science community, what is the science that's highest impact that you would want to do, and how might we work with you to create opportunities to do that science. Some key areas for the exploration focused science that we'd like to talk about. So de-risking crew survival, mental physical health and crew support and performance. So how do you optimize crew activities and crew, the quality of crew performance and health? How do we understand the new locations that we're going to go to, the environments of these locations? We need to understand how these environments are going to affect human activities. And we need to understand how human and robotic activities are going to affect and change these environments. And finally, we want to look for potential resources at the moon and Mars and to understand their potential to support exploration. So these are things that we are working with our science advisory structure and with our member states to refine, work on the priorities and the approach to implementing these within the program. And another important element of this is we're being encouraged very strongly to increase our engagement with European universities and research institutions as a part of how we do this. And so also looking for ways that we might become more inclusive and more involving of the scientific community in how we do this. So just some, again, pre-decisional, but something just to emphasize that these are some of the priorities we're expecting to come out. So resource prospecting, so determining presence, abundance, distribution, and potential utility of resources on the surface of the moon. This is important in terms of if we ever want to make decisions about whether we're going to use resources on the moon, and if so, how, and how we're going to regulate that, how we're going to govern that, that's something that we're going to need to discuss. And to do that on the basis of a sound knowledge of what's there. Secondly, the environment and the preservation of that environment, so characterizing, understanding, and monitoring that environment at the moon and at Mars. So these are kind of two I guess, sort of planetary sciencey kind of orientated priorities that are likely to appear. I think it'll be more kind of human health and performance related. So looking at countermeasures for the effects of the environment on human health and performance. So understanding the risks, understanding the challenges, and then creating countermeasures for those things. And then looking at the creating environments where humans can live and work in these locations. Those are likely to be the kind of priority areas for what's coming out of this and the way we would emphasize our future scientific research. Other things we're looking at would be landing sites, understanding geodesy and positioning, looking at return sample sites. So return sample science is something that's going to be prominent in the future of our program too. And then looking at exploration-enabled science, there's a number of different topics that we're likely to want to cover. So looking at fundamental physics and astrophysics, material sciences, fluid sciences, and the way we use things like microgravity and partial gravity, looking at these place and planetary environments from a pure science perspective, and also the sort of fundamental biology and human health research that we could do at these locations, and fundamental planetary science too. So something we're also likely to try and emphasize here are exploration-focused science products. So these are, once we've done that research, so if we want to do research, say into an environment and how it affects exploration. We need to then turn that research into something that someone who's not a scientist, who's developing, for example, a lander or a rover, can use. And so we're looking at, okay, what are the products that we can derive from the research that we do that would become useful for somebody to use to do what they need to do? So some examples might be a resources reference model. So something which comes, this is the go-to place that says, this is what we think is on the moon and where it is. This is what we think it looks like. This is what we think it means to get that out. And this is our reference, what that looks like based on the data that we have. We know that's wrong, but it's our best estimate based on what we know. And that model can be used to inform decision-making. It's clear then what the uncertainties are and the work that needs to be done to refine that model. And that should be a model that someone who comes from a non-space environment or a non-space sector could look at and understand what it means. The same for an environment model, or we could look at site maps. The sample library would be the samples that Europe has access to for scientific research. We could have things like a material properties handbook. So if somebody wants to understand what the materials are like on the moon, they can go to that. And that is the reference. And one of our jobs as a sort of science activities within exploration would be to improve these models to produce products that are useful to the users of space exploration. So I hope that was somewhat clear. So I think at that point, well, maybe you could change the slide. I can't, don't seem to be able to do it. Very good. That point, maybe, I talked a lot of things about kind of the future program, what's there now. Maybe now's a great time to just, if anyone's got any questions or comments, just to break this up a little bit, so you don't have to listen to just me. If anyone's got anything that needs questions, now would be a good time. I think there's a couple of floating mics somewhere. Is there a mic somewhere? All right, or just yell, and I'll repeat the question. Right, very good.
Thank you. David Alexander, I'm the director of the Space Institute at Rice University in Houston, Texas. One of the things that NASA's done very successfully over the last several years is this partnership with commercial entities, not just big contractors. And we're seeing a lot of interest in Houston from member states, from ESA, interested in developing commercial connections to the United States. How does that fit in the context of ESA and what you're trying to do on the moon? Because I think you mentioned commercial right at the beginning, but I didn't see much on that. But from your perspective, where does that partnership fit in with truly commercial companies within the European regime?
So something that we are, commercialization and finding commercial ways of doing things is one of the things that we're trying to work out how to do. Now, in lunar exploration, there's a number of different ways that can be done. We are, through partnership with NASA, working with some of the commercial lander companies already. We also have, I think, 2 activities currently where we have procured flights or are procuring flights for ESA hardware. And as we look into these new capabilities, commercialization and commercial access to these things is one of the things that we're investigating too. And I'll talk a little bit later on about one commercial, rather different commercial model that we're starting and experimenting with a little bit at the moment. So it's there, but it's a little new for us, but it is something that we're working towards.
Hey, James, Corey Hibbets, APL. Great talk. Thanks for everything you've said. Question is more related now to ISRU. And what are your thoughts on how to enable a prospecting campaign for water ice, from an international perspective, not so much from a technical one, but from a programmatic one, which may be even more challenging than technical?
Okay. So I don't think there's an ESA position on that. So I'll give you a personal view. Right. I think if we want to understand resources to produce a model of what's there that has credibility and meaning, that's only going to be possible by bringing together the data and the analysis that's coming from all of the different missions that we're observing, and by planning our missions together internationally in a careful and strategic way. That requires coordination. It requires a coordinated campaign of missions and measurements and analysis. So I think that is a natural evolution of what we're doing. I think I think at the moment, there is not a single approach to doing that. There's not a single organization or group that is responsible for that. But I suspect it's something that will emerge because I think it has to. And I hope that by the kind of activities you're talking about and by creating a reference model that we can point at and go, that's what it looks like to the best of our knowledge, it becomes much easier to structure a conversation like that with international partners. I think a complexity to that comes with the commercial element. So I think agencies have a certain need, rationale, certain set of rules and expectations about how this is done, which in some cases will differ from that of the private sector. And I think the balance of what the public sector and private sector need and expect from that kind of coordination and that kind of activities is something which will be interesting to explore. By the way, I know there's a lot of ESA people in the room. So in a minute, I'm going to get you just to identify yourselves. And then also, please feel free, if you're an ESA person, to jump in. If I say something incorrectly, or you think I've missed something, please. All right. And we maybe just take two more, and then I'll probably have to move on. Yeah.
I was obviously interested to see your bullet points about integrations with universities. Can you expand on that? What sort of things ESA has in mind that it's not doing at the moment?
It's a good question. I don't have a single answer for that. And the I can say is that there is a direction to find ways of creating much deeper connections and links. So that could be through the way we use things like research fellowships or PhD studentships. It could to do with common research. It could be to do with the way that we perhaps bring personnel, people, analysis work of what universities are doing in a much deeper way into the way we manage our program and select our priorities and do our mission. So I think there's a lot of different potential models. And I think one of the things that we're going to need to do over the next months, years, is to find new ways of doing that. And so I think would welcome ideas or thoughts for me or any of these colleagues here for how that might work, or your own thoughts on what would work for you. But I don't think we don't have a single model right now how it's going to work, just to give you some idea of the intention. And then I think there was one here. Yeah. So what I can say is that ESA is working with China in a number of areas. So we have the SMART mission, for example, which is a science program mission, but not an exploration program mission. We had, and I'll talk about a bit more about this later, an scientific instrument on the Chang'e 6 mission. And we are interested in exploring what future partnerships with China might look like in space exploration. I think it's possible to say much more than that right now. I think it's an open point at the moment about whether or not we would be able to participate in future Chinese missions. I think I can say that what they're doing is impressive, extremely impressive. And definitely from a scientific perspective, there's enormous benefit in cooperating and finding ways of working with them. From a political and programmatic level, I don't know the answer today about how or if we will.
Could I ask you how, I'll stand up. Could I ask you, and I just don't know the answer, where you put your repository for data? So you talked about the ESA missions. Do they end up in the planetary data system like the US has, or do you have your own repository? I just was curious.
So ESA has its own data archive.
So you have your own data repository. Do you, when you collaborate like on Eclipse mission, which is a collaborative mission, do you then deposit that data in two different repositories?
Yeah. So if I take Prospect, for example, and data about there is the project scientist for Prospect, the data from Prospect goes into our planetary science archive and also into the PDS, NASA PDS, I think. Yeah. So, I mean, with any given partnership, it might look a little bit different, but in general, all of the data that we generate will go into our planetary science archive. And how it works with a partner, that's something we can decide on a case-by-case basis. in the interest of time, I will carry on. Right, so destination moon. Here's some of what's going on at the moon right now. So we talked about Gateway. So Gateway is and Orion ESM. So here we have the set of Artemis flights and the things that we're contributing. So we had the Artemis 1 flight. So ESA provided the service module for that, the back end of Orion. So that's this bit here. With Artemis 2, we're also providing the service module. That'll be the first crewed flight to the moon since Apollo. Then we'll have the first flight of Gateway and Halo. So on Halo, we're providing something called Lunar Link, which is the communications subsystem to the surface from the Halo from Gateway. On Artemis 3, which will be the first human landing, we're providing the service module again for Orion. On Artemis 4, we're providing the service module. We're also there providing the International Habitat, or IHAB, Lunar IHAB for the Gateway. On Artemis 5, again, service module, and also providing something called Lunar View. Lunar View is the windows for Gateway, so you can see what's going on outside and see the moon from the Gateway, but also a refueling system for the Gateway to allow it to function for longer. And then on Artemis 6, we're also providing the service module for Orion. And so these are just the things that we're already committed to do. We're already in development for this. There's hardware being developed for all of these things right now. We also have lunar payloads going to the surface during the 2020s. The Exosphere mass spectrometer I'll talk about in a few minutes. We have the LandCam X, which is a technology demonstrator for a landing camera, precision landing camera. And actually, that one's actually our first time that we as ESA have procured a commercial flight with a private sector lander. We have a laser retroreflector going on Intuitive Machines 3. I'll talk a bit more about that a little bit later. And Prospect, which you heard a great talk about earlier from Dave Heather. And there's lots of Prospect team members here as well. And we'll talk a bit more about that in a moment too. But the one that's not mentioned here is NILS, negative ions at the lunar surface. And I'll talk about that in a moment. The big development for us at the moment is Argonaut. So Argonaut, you see an image of here. This is the this logistics lander, which is intended to provide support services, logistics support services, primarily to future human missions, but also can provide robotic equipment and stuff to the lunar surface too. Some key facts on Argonaut. The first mission, which I'll talk a bit more about in detail in a minute, is planned for 2031, no later than 2031. It's been called ArgoNet, and it's going to focus on navigation, energy provision, and telecommunications at the lunar surface. The landing capacity we're building is based on having 9.9 tons of launch mass in total at the beginning of the mission on an Ariane 6-4. And we need to deliver around 7.5 tons to the lunar surface over 5 flights. We're currently in the process of selecting the specific engines that we would like to use for that mission. And we're looking at having 1 flight and then perhaps 1 to 4 optional flights after that. The intention is that we'll have this first mission, which is the moonlight navigation demonstration, and then increase that with the Mark II, and then Mark III, providing eventually global access and moonlight navigation. The Argonaut is supposed to provide a generic interface between the LDE, which is the lander descent element, and a passenger to accommodate a wide range of different missions. And intentionally, we're looking to provide precision landing of the order of 50 to 100 meters accuracy for this mission. One of the key things actually is we're trying to work on building in radioisotope power systems into this as a key enabling capability. There's a lot of work going on in Europe now to develop these radioisotope power systems as a key element for the future in order to allow lunar night survival and operations. And we want to use Moonlight, which is this communications network for communications. And this should all be included as a part of our contribution to the Artemis program overall. And then in the longer term, we're looking to how we might use Argonaut to develop other systems into an end-to-end sample return architecture, which is really something which is in preparation. So I'm not going to talk a lot about these elements other than just to indicate these are perspectives that are on the horizon that we're looking to. So one of these will be a lunar prospecting and sample collection rover, and there'll be a phase A study coming out for that fairly soon. We're looking at a lunar base camp as a concept for the future, and cislunar cargo return vehicle as a capability for the future too. All right. Any questions on that? Yes, so for the Argonaut, Manon, where's Manon? Right, Manon with a hand up over there has a poster on Argonaut. Anon is from the Argonaut team in ESA. Very good. Okay, so I'm going to talk a bit more about some facilities, things that you either can access or might be able to access fairly soon. The first of these you heard about earlier on, which is the Lunar facility. So this will be a facility for actually primarily operations, testing and preparation, which is being built at the European Astronaut Centre in Cologne in Germany. It can provide a simulated lunar environment with lunar regolith, simulated lunar terrain, with operational capabilities next to it, with ways of rehearsing missions, including gravity offsetting as a way of rehearsing and practicing for future missions for research and operations preparations. So there's a great talk on that earlier on. If you've got any questions, please. Is Freya still here? There you go. So Freya at the back, they gave the talk earlier on. So please go and have a chat with her, or you can come and talk to any of the ESA team. Is Cameron here? No. Okay, come up here. Okay. So, but we have the spaceships, which are facilities where we have teams of people looking at very early TRL, very novel systems. These actually, we talk about partnering with universities and research institutions. This is one of the ways that we do that a lot at the moment, working with master students and research fellows to develop these very, very low TRL concepts and try and show their viability. We currently have spaceships, one at EAC in Germany, there's one in the UK, and one in France. Other facilities that to be aware of is Vulcan. So Vulcan is an analog curation facility where we have simulants, analogs of extraterrestrial materials, which can be used for science or engineering purposes. Vulcan provides an expertise in this, provides access to these samples in a quality assured and managed way, well curated way to ensure that when you use a simulant or use an analog, you know what you're using, you know it's appropriate for the task in hand, and it's done in a careful and curated way. So Vulcan is providing support to a number of different activities. Currently, the kind of things it would do, it can provide requirements descriptions for analogs that you might want to use and recommendations for analog options. It can provide access to analogs from providers, or for some extent with the things that we actually have in-house within Vulcan today. It can provide characterization of analogs and their properties and compare those with extraterrestrial samples. And it can develop the curation and characterization procedures for analogs as well. This is a kind of an end-to-end process for analogs and a competency for analogs, which is open to ESA, but also to the community at large. Did I cover that okay? Yeah, great. Good point. There was a table at the back, all about Vulcan, with stuff you can look at, things you can take away, postcards and all sorts of things. So go and talk to the people at the back. Thanks, Brad. Right. Final thing I just wanted to draw your attention to are ESA parabolic flight campaigns. So parabolic flights, you probably know they are aircraft, fly very high and then fall from the sky. So if you don't mind falling from the sky regularly in an airplane, this is for you. So we've been doing parabolic flights for a very long time, since 1984. We've had more than 80 campaigns, and typically this is done to simulate microgravity. But we also now have an almost unique capacity to simulate any G you like up to 1G. So simulating 1G, not that helpful, less than that, more helpful. So we can do Martian G, we can do Lunar G. And we have done several campaigns at different gravity levels. And one of the things we are considering doing, so first of all, I can say that there's a continuously open research announcement. If you have proposals for the parabolic flight program, then it's really worth putting those in. So we're looking to try and expand participation in that program in general. One of the things that we are thinking about is having a dedicated lunar gravity campaign. So we have done lunar gravity before. So we've done experiments to look at how different processes occur in partial G in lunar gravity, looking at how different technologies like 3D printing work in partial G. It's actually the only way to create sustained large-scale lunar gravity field for experiments. We're interested to understand what serious interest there is in access to Lunar G for research. A lot of people like to do parabolic flights because they're enormous fun. It is enormous fun, but you do need a reason to go. So if you've got a real serious research reason or research use for lunar gravity, we would be really interested to get some idea about it, to get some idea of the scale of serious interest and whether or not it is worth creating a dedicated lunar gravity campaign. So please come and talk to us about that. If you have ideas about it, we'll get in touch. That was facilities. Any burning questions? Otherwise, I'll tell you about some things that happened this year. Great, things that happened this year. We flew stuff this year for the moon. So the first of these, and I also want to make sure there are lots of talks going on this week, and I don't want to rain on anyone's parade. Like, I just want to point at people's talks and point at some of the places you can get information from. I'm not going to try and cover it in its entirety here. But the first thing I want to draw attention to is the Peregrine Iron Tap Mass Spectrometer, which flew on CLIPS mission with Astrobotic earlier this year. This was done with ESA providing the exospheric mass spectrometer, the kind of the core instrument within the PITMS package. That mission, I guess many of us followed it. It didn't make it to the moon, but it did produce some great data and was an enormously successful, actually in many respects. And there are a couple of talks going on here this week. So one from Bob Cohen, who I think left the room, which is on Tuesday, and Roland Troutner, who may or may not be in the room. I think he was here earlier, may have left. Okay, which is going to be on the EMS instrument, which will also be on Tuesday. So this was exciting. This was the first time that actually we had within our program, at least, anything going to the moon. The second thing, which was actually has been an enormous success, has been the negative ions at the lunar surface. So Ruth was asking earlier about our cooperation with China. This within lunar exploration is the first time that we had ever worked with China. It was an enormously rewarding experience. It was very, very difficult at times. We learned an awful lot about what it means to work with the Chinese, how they have different ways of working to us, culturally very different. It was a fantastic learning experience. I think it was a lot of work on both sides. In the end, the equipment was developed very, very rapidly and was delivered, and it flew on Chang'e 6. So this is Nils at the lunar being mounted onto Chang'e 6 for flight. And maybe so actually, some of you with long memories will remember this next slide. Maybe it goes back. It goes back. There we go. Right. So I'm going to talk a bit more about Nils because I don't think there's any presentations on it this week. So I want to talk a little bit more about negative ions at the lunar surface and what it was. So for those of you with long memories, that's the ESA lunar lander that was cancelled in 2012. But the diagram still remains valid. So on the moon, we have this integrated lunar environment. It includes meteoroids raining down. We have magnetospheric and ions and electrons coming from the Earth's magnetosphere when the moon is passing through our magnetosphere. We have galactic cosmic rays, solar energetic protons from the sun. We have the solar wind, which is primarily hydrogen and helium ions. We have ultraviolet light striking the surface. And this creates a lunar environment with mobilized dust, with charging, and we'll have photoelectrons and ions generated at the surface. And one of the ion populations we would expect to see on the lunar surface are negative ions. So experiments indicate they should be there, models indicate they should be there, but they had never been measured at the lunar surface. So firstly, the physics of what happens when you put an airless body near a star, that's important fundamentally, but also understanding this environment in its entirety is important because we're going to want to live and work and operate in this environment. So we need to understand it, but we're also going to alter it. We are going to alter the environment on the lunar surface. And so one of the things you would like to do early on is to make the first measurements of some of these environmental parameters that we haven't measured before. And so NILS was intended to measure negative ions at the lunar surface for the first time. And to do that, it needs to operate for about an hour. So NILS was mounted, and you can see it there on the Chang'e 6 spacecraft, and was launched from China on the 3rd of May. And I know it was the 3rd of May because that's my wife's birthday and I wasn't there. We were delighted we turned up at the base off to find that the Chinese were kind enough to put a large ESA logo on the side of the launcher. Next to that, you'll see the KNES logo, and that one actually is from Pakistan. It was a fantastic and beautiful launch, apparently. It was, in fact, almost impossible to see because it was incredibly rainy. So one of the things actually was so 2 minutes before the launch, standing outside, and the heavens opened. Rain descended, like torrential rain, thunder, lightning. We're like, they're never going to go. They can't go like this. They can't. They went like clockwork. At 27 minutes past the hour, they were supposed to go, and they went. And we didn't believe it, but you could see the flash as the thing happened. You could feel the noise and a glow through the rain. There was a thick cloud of rain as it went up. But then that was it. We were only 3 kilometers away, so it was quite a dramatic experience just to be that close to it, even if you couldn't see very much. So apparently, from this picture, it was a beautiful plume, but you couldn't really see very much. It was very wet. You can't see from this just how wet we all are. But we all look great in wet white shirts. So these are some of the ESA guys, but note the other contributions internationally. The Pakistani team. This is Simone Delagnello. Some of you will know him from INFN in Italy, provided a small laser retroreflector. We have here the ESA and IRF team from the Swedish Institute of Space Physics who built NILS. And my colleague Neil, who was the technical officer for this and dealt with all the pain. And then these people in their matching T-shirts, which we probably should have got ourselves, are the Dawn team from CNES. So Dawn was an instrument from CNES looking at alpha particles, looking for radon as a proxy for volatiles and transportation of water and other volatiles on the surface of the moon. And I think this is extraordinary. This is and you can't really see it in this image, but just there's a little green box, and inside that box is the NILS instrument on the surface of the moon. And so it's quite something to see things you've been working actually on the surface of the moon. So it landed, it worked. We needed an hour. In the end, I think we got around 3.5 hours of data. We know that we detected negative ions for the first time on the lunar surface. That analysis is ongoing, and we're expecting some publications to come out from this in the future. So I think for ESA, that was the first. So that was the first ESA science on the surface of the moon. It was our first cooperation with China. It was the first measurement of negative ions on the lunar surface. So a number of firsts for us. And a good experience learning to work with the Chinese. Of course, the samples from Chang'e 6 will return to Earth fairly soon. And finally, the other sort of success story from this year is we have delivered, ready for flight, a new laser retroreflector developed with INFN in Italy. So this has been delivered to Intuitive Machines, who are flying this. It's a partnership with NASA. This is a payload which will provide very precise laser ranging to the moon. It's a higher quality of or higher precision laser ranging than can be achieved with the Apollo laser retroreflectors that are there at the moment. That's important for lunar geophysics, but also for geodesy. And actually, we've learned since it actually can be a really important part of how we build a precise geodetic reference frame with exact surface locations as a contribution to moonlight and surface navigation too. So it has a multifaceted benefit for us. And what you see here is actually what you see here is an actuator. So the thing lands, and then it can actuate in order to point itself towards Earth to allow for precise laser ranging from Earth stations. So that's all stuff that we did this year, which from nothing, I think was actually quite a lot. So for those of you who've been around for a while, that's the culmination. I think a lot of work for a lot of people in this room and a lot of people outside too. So for everybody who's been involved in getting those things done and getting to this point, thank you so much to everybody who's done that. Any questions? Awesome. Right. Okay, some things that are in development now, right? So Prospect, you heard about earlier on. David told you all about it. We have the critical design review. It's ongoing at the moment. David gave a talk earlier. There's another talk on Tuesday about the, and NASA are expected to finalize the selection of the lander for that. It's a cooperation with NASA, of course. And it's also worth noting, and Sarah Bozeman has is Sarah here? Awesome. So Sarah Bozeman back there has a talk later in the week on Tuesday about the landing site selection. And so an enormous amount of work went in also to helping to select the landing site for that mission for the CP-22 delivery. And we're very excited to see who gets selected to fly us. The other thing that's coming on is EMS on Lupex, and Roland Troutner has another talk on that on Tuesday. So we talked about the exosphere mass spectrometer, which was on the first CLIPS mission. This is the same instrument adapted now for contribution to the Lupex mission from Japan, which you heard about earlier on today. So that again is part of this international effort to understand, explore, to quantify resources and polar ice on the surface of the moon, as that's again something that ESA is participating in there. And so we're planning to develop and deliver that hardware. And actually, I can also say that we have Kaiser Italia on contract now for the development of that instrument, working with Open University and others. And then finally, for the lunar surface payloads, we're now planning, and you heard earlier on about the Rashid 2 rover and the plans from the United Arab Emirates. We're also now working with them. Again, an instrument which is derived from Prospect. So it's worth mentioning that Prospect is the core package. EMS comes from that package, and so does the permittivity sensor we're deploying here. So this is something that would go in the wheels of the instrument of the Rashid 2 rover. I'll be looking for making measurements of icy soils and near surface rock abundance and distribution. And there's another talk on Tuesday. David. It's Rashid 3 now, not Rashid 2 now. Okay, very good. Thanks. Okay. So then going up from the lunar surface up into orbit, we talk about like environmental measurements. We have 2 big developments ongoing for the gateway. The first of these is ERSA, which is the European Radiation Sensor Array. It's a suite of radiation instruments which are going to go outside gateway. One of the unique things here is we're combining instruments that have been developed over a number of years. So there's the what's called the Standard Radiation Monitor, or SRAM, which is kind of quite an old instrument, about 20 years old, in fact. And combining that with, and has been all over the solar system on ESA missions, not that particular one, but the same instruments, combined with next generation space weather instruments too. We're going to put those together so we can do cross calibration outside the gateway, provide a really comprehensive analysis of that environment. Combined with that, we have the internal dosimeter array, which would be a radiation suite of instruments that are going to go inside the gateway, so we can look at how the internal radiation environment that crew will experience compares with the external radiation environment that's coming in. And that combines with international partner contributions. So there's a dust instrument, which is coming from JAXA, which has been integrated with ERSA. And we also have JAXA instrumentation integrated with IDA to look at radiation dosimetry. There is, Laurie mentioned earlier, the Hermes instrumentation, which is also outside Gateway, which is looking at the integrated environment, looking at plasma and fields. And so together we have radiation, plasma, fields, external radiation too, as a package. And something I talked about the commercial bit earlier, this is something again, which is a little bit new. So we are planning, it's kind of an experiment, to see how it works and whether we can do it, to purchase data from a completely private sector activity on the moon. So there is an instrument called the Puli Lunar Water Snooper. It has been developed by a small company called Puli Space in Hungary. This instrument has been built, delivered, and is integrated with the Intuitive Machines 2 mission. In fact, there are 2 of these on that mission. There is a rover and a hopper, and the hopper will move to different places on the surface while the rover moves across the surface. And this instrument will aim to measure neutrons at the lunar surface to determine the hydrogen or water abundance near the surface, in about a meter of the surface. So this is a pretty innovative instrument. It uses a technique using sort of standard off-the-shelf CMOS detectors with a neutron converter to convert neutrons into alpha particles that can be detected by that instrument. The hopper will accumulate data from a number of different locations on the surface, including inside a permanently shaded crater for the first time. And a data set will be produced, and ESA plans to and is working to procure that data set for us. And something that we're planning to do with that is to select an ESA scientific analysis team from the community, create an analysis opportunity to put together a team who would have exclusive access to that data set for science after that mission takes place. So there are people from Intuitive Machines either here or going to be here. I saw Tim Crane earlier from Intuitive Machines. I think he's here yet. Ben Bussey, who is the chief scientist from Intuitive Machines, will also be here later in the week. And so we'd be very happy to answer any questions you have on that. But that is something which I don't think has ever been done before, is that a mission has gone to the moon to make scientific measurements completely as a private sector initiative, which then an agency has come and said, we would like to buy that data from you. So it's an interesting experiment. It's really commercial, and let's see if it works and how that goes. But I think that's quite an exciting thing to be involved in. That's going to fly later this year in November. Very good. Any questions? See on there.
That's very interesting. Just to point out something you didn't talk about, next year we launch Surrey Satellites Lunar Pathfinder, which has been heavily supported by ESA and actually also carries a couple of experimental payloads for ESA. So it carries a GNSS weak signal detector, so that will allow us to determine our orbit using the broadcast from GPS and Galileo from the Earth with a special high gain antenna. And the other payload we carry for ESA is a radiation monitor. So yeah, just to fill in the blank, so that's happening as well. So Lunar Pathfinder is a precursor to the full Moonlight system, which will come a few years later.
That's good. So thank you very much. Yes, it's very true. Thank you. So yeah, Lunar Pathfinder, something which we're very excited about, and has been, I guess, quite a number of years of work to get to this, and that's going soon too. Thank you. All right. And then there's a number of preparatory activities that are taking place now too. The first I mentioned, ArgoNet, which is the first Argonaut mission. So that's to provide navigation, energy, and telecommunications and charging services on the surface of the moon. We're also considering a mobility demonstration element within that mission. And one of the things that we would be also, or we will be doing, is providing opportunities for scientific payloads within this first mission. At the moment, we don't know what capacity will be on the platform for scientific instruments. That's something which will be determined during the very early phases of this work. And that's once we know what the scope is for scientific activity, for scientific payloads within this mission, we'll be creating opportunities for that on that first mission. It is worth noting that with the navigation part in particular, we see also a lot of scope for scientific research using the precise timing and location data or information and capability that would come from that navigation payload too. We're working with our navigation directorate colleagues to develop a science case around some of those things. Another thing we're working on is we've got a payload servicing station. So this would be a standalone system that's deployed on the lunar surface by crew within Artemis missions. This would provide a centralized service, so power, communications, data handling for surface deployed payloads. This is something, so for those of you who are familiar with it, this would be like the OLSEP package that was on Apollo, where we would have a central station that external payloads can then plug into and use those services on the surface of the moon. We'd be looking to use that to enable long duration measurements of 2 to 5 years, with the idea that this would be used over several missions with an evolution of that capability possible. We're preparing a phase A/B activity, and you should expect to see probably in the next few months an invitation to tender coming out for that phase A/B activity. We're also looking at how we might use that. So you'll see a talk, I think it's tomorrow, right, Francesca, on this, which is called AstroLeap. So this would be an astronaut deployed lunar environment analysis package. This would look at the deploy instruments that would look at the complete integrated lunar environment to understand it. We have a facility definition team, which was put together through an external call. That facility definition team is defining the objectives, requirements, the scope of what we might want to do this with us. And the intention is that we're going to have an instrument maturation activity that would follow that, where we'd be able to select a number of instruments which we could invest in to try and improve the maturation of those ready for next steps. And Francesca will talk more about that tomorrow. We also have Asteria. We have a talk also tomorrow from General Gell, so over here. We're going to talk about Asteria. So this is going to cover the external dust environment and impactor environment around the gateway. This will look at the evolving environment you have around gateway, the impactor environments experienced by deep space platforms, but also look at a unique once every 22-year event where interstellar particles are focused into the inner solar system, and we can observe them from gateway using this package. So that's something, again, where we have a facility definition team in place, selected through an external call, who are helping us to define the scope and the requirements for this. And we're expecting to have a phase A/B activity invitation to tender issued in the next few months to develop that package further, ready for a decision at the next Ministerial Council meeting. Metis is another platform we're looking at for Gateway. This is a multi-purpose exposure testbed in deep space, looking at the exposure of biological and material samples to the deep space environment on Gateway. We have, again, a facility definition team in place. We're looking at what the scope of this might be. I think elements of this may end up making more sense inside Gateway than outside, but we're looking really at the scope of what biological research could be done outside Gateway, building on things that are already being done on the International Space Station with exposure platforms there. And again, we'd expect an ITT invitation to tender to come out in the next months for this package. And with both of these, at some point when we've agreed with international partners on the next steps, we'd expect announcements of opportunity to come out for the scientific teams to support them. Some of you may also be aware of or have payloads in our reserve pool of science activities at the Moon. We had an announcement of opportunity in 2022. The idea was to select a pool of payloads that we could have on the shelf that we know we could develop relatively quickly within 3 years for missions if they turned up. So what we had experienced was that international partners, others would come to us and say, hey, we've got a mission going to the Moon. Would you like to participate? Or we'd become aware of opportunities to participate in things. But the turnaround time for decision making was so fast that there was no way to issue a call or do a proper selection process. So we needed to have something that we could go to, a pool that we could go to. And so that was the idea to put this together. For all of these activities, our first step was to put together activity requirements documents. What that means is that's a document which outlines this is the scope of what we're going to try and do. And that gives us a basis for taking financial or engineering decisions on the next steps and understanding whether or not partnership opportunity comes up, whether or not it's compatible with a given payload or activity. We've got 2 payloads out of this tool, which we're now working further on. One is the permittivity sensor, which comes from Germany. I think Philip Rice is here somewhere who is working on that from the Technical University of Munich. And the neutron sensor, which came from the Czech Republic, which we're looking at maturing the concept on a little bit because we see an opportunity, but it's not quite ready just yet. So we're doing some work to prepare that now. We're going to be reviewing these activities within the pool during 2025 and 2026. I think the key thing here is that we can't guarantee a flight for anything that comes into the pool, but we are actively working to find opportunities for things that are there. And then I think it's the final one now. There we go. Right. Almost final one. Right. I'll come to that in a minute. Right. So some of you also may have been involved in a call which came out the end of last year for small missions. So the idea here is that we would have within the next program period, which starts in 2026, we would begin the development of a small ESA mission to the Moon. And so a call came out on the Open Space Innovation Platform. We received an enormous number of proposals for missions. An extensive review process was undertaken for all of those proposals. It was an enormous work. I understand that pretty much everybody should have received feedback at this point. I know that it was quite slow getting feedback to some of the teams. If you have any questions if you were involved in one of these and you have questions about what's going on, please come and see me. We can talk about that and how we might, if you haven't heard anything or if you have further questions, we can follow that up with you. The next phase for those that are being down selected following this process would be to have a pre-phase A study that we would pay for. And then that would be used then to down select further for the ones that we would invest in phase A/B activities for. And so there'll be a continuous down selection process coming forwards with a view to going to the full development during the next program period for a flight no later than 2030. Yeah, so again, if you have questions on that, please, you can ask them now or you can see me afterwards and we can talk further about that. I'm not allowed to tell you which ones got down selected or how many or what the next steps are in detail, but I can certainly tell you that on a one-to-one basis what the status of your activity is. So in terms of things that are coming up in the next year, we think at the moment that could be of interest for you. We're going to have the data analysis science team selection for the Puli Lunar Water Snoper. We're going to have the payload servicing station phase A/B invitation to tender, which may be of interest for some of you perhaps coming from industry. We're going to have the Astroleap Environment Center maturation call. We're going to have the Asteria Phase AB invitation to tender, the Asteria Science Team announcement of opportunity, the Metis Phase AB invitation to tender, the Metis Science Team announcement of opportunity. I think there'll be potential announcements of opportunity associated with international partner payloads on Gateway. Don't know what those would be yet, but within Gateway, there is a principle that all of the resources on Gateway for Science are available to everybody. So anytime an international partner flies a payload, the science should be accessible to you too. We will have the Prospecting Rover Phase A science definition. I don't know exactly what that looks like right now. We're working on it, but there'll be something coming up, which I think will be of interest to some of you. We'll have the Phase A invitation to tender, which is coming out. There's possible new missions of opportunity with international partners. I just don't know because they just pop up and then we have to respond on a pretty rapid ad hoc basis. So I would expect that there'll be something along those lines. The NILS data will end up in the Planetary Science Archive as a new data set you can use. The following mission, the following phases will start with the small missions activities. And you should have a new, if you like laser ranging, then there'll be a new laser ranging station at Reiner Gamma that's never been there before that you can shoot lasers at whenever you like. And that's it. I will absolutely shut up now. You can ask questions if you've got any now. I think the booze should be just about ready. You're welcome. Any questions before we finish, or any comments? Any feedback? Like, I genuinely would like to know, like, you know, for those of you who've been around for a while, right? If I'd stood up here 5 years ago, this would have been a very short presentation. There's a lot happening. And there's big ambitions. And I think that for the first time, lunar exploration is really a big priority for Europe. And I think that's really exciting for all of us. So, there you go.
So thank James. I just want to thank you. You absolutely said this. 5 years ago, if you stood there, we had very limited number of activities that were taking place. So I'm so grateful that you actually accepted an invitation to come here tonight and share with us what's going on. What struck me is that bullet point that you had about deeper engagements with the university. I mean, all of this, what you actually showed already has quite a lot of interaction with universities across Europe, right? Because much of the scientific basis for all of those technical development that takes place happens, in universities. So how else do you actually see universities actually contributing or gearing up to get ready for it? Because it's a tremendous opportunity there for the next at least 10 years, if not beyond.
So what we're trying to do with this new strategic part I talked about at the beginning is to be clear about, I think for the first time, you're really clear about these are the things that we are going to prioritize, that we want to put our efforts into. And I hope that then going to the deeper definition of those things, I think is something where we're going to need to work with the scientific community on. And then as we start to develop those things, for example, if we want to develop an environment and effects model, like that's going to come from research and work that the universities are going to do. As we define what the needs are, we're going to have to work with the scientific community to do those things. So I think it's clear what the needs are and how we're going to need to work together to achieve those. But the actual mechanisms for that, I'm not sure of how we deepen that. I'm not quite sure right now. But I think what I imagine is something where universities, research organizations are much more deeply involved in the actual way we formulate these things and put them together. But I don't know right now exactly what that'll look like, but it would be really welcome ideas, thoughts on what you think would be a useful way for you to engage more. I know one thing that because we have tried to engage on lots of occasions in different ways, is that the agency is pretty opaque. So you provide inputs to us, or we work with you, we do something, and then it disappears into the agency and you've got absolutely no idea what's going on, right? So you can't see the wheels are turning. And I don't know how much of that it's possible to even expose. But I think that we need to find ways of perhaps creating a better feedback loop with the scientific community so that you have better visibility about why we're asking for something and then what we did with that information when it came in. And I think that's going to become much easier once we have a very clear set of objectives and drivers. And I think that's where we're going. We're getting clear leadership that this is what we should be doing. And once we have that, it becomes much easier to engage and much easier to provide feedback. So I'm pretty optimistic that a year from now we'll be in a much better position, and that'll be better for you. And I see Nicole nodding because she knows.
It's good stuff. Yeah, very good. Okay, so are there any questions? Yeah. Wow.
Hi, Barbara Cohen, Nessa Goddard. I love this portfolio and this vision that you're laying out, and I'm so glad that you've stuck with it and so many people have stuck with it to build it. One of the things that strikes me is you've got a real range of activities going from like human exploration all the way down to very small things. I know you and I have talked about how we managed PITMIS and how we had to tailor that process really far down to not overwhelm it. For human exploration, obviously, you have a huge process. So could you talk a little bit more about what you're doing within your program for managing risk appropriate to the opportunity and tailoring your processes so that you're not overwhelming the small opportunities with the process that you need to have associated with the big opportunities? Like it's not a gotcha question. I'm really honestly interested in this.
It's good. Right. Any development colleagues here? No, Roland's not here. Okay. So one of the things that I think, and chip in ESA folk, is you're right. I think we are an organization that is largely structured for building really big things. And if you want to build something that is smaller or lighter or has a very different risk associated, if you want to put a laser retroreflector on a commercial mission to the moon, you don't need to apply the full weight of our standards to that because it's just not going to work. And there's no need. It's not appropriate to the risk that we're taking or the money that we're spending. So I think something we've worked really hard on at the payload development level is tailoring our processes and trying to be really flexible about it and taking some risks. The NILS instrument you saw there, that was, again, quite unorthodox. But that mission that came together in 2 years. From the let's do that to we deliver the flight hardware was 2 years. And that required a lot of flexibility. Also working with a Chinese process, which was completely alien to us. So I think we've had some success at that in terms of, but I think there is always a tension between in a program that is developing gateway and is developing a small payload to go on somebody else's commercial lander. And I don't think right now we have a really well structured process for how we differentiate between those things. It comes down largely to a case by case basis, and then the technical responsible making judgments about what they can do, and then trying to tailor the process appropriately and get the right authorization to do so. But it's a tension that exists, but there's a lot of work and a lot of thought going into how we do that. But also in terms of our activities and where we invest our time and effort. Like one thing that we struggle with is if you're managing the development of a payload, the amount of effort involved in that in terms of technical oversight and project management and product assurance and all those things is not that different from something that's very, very big. So the internal costs associated with that also become more of a challenge to manage. So there's a lot of different levels to those things, but yes, it's a thing.
I think we are getting close to getting some hydration. Go ahead, Nicole, do you have a comment? Yeah, before one, okay. Final, I think.
I kind of lost a little bit my train of thought, but I wanted to come back to the conversation that you had with Mahesh and to your comment on the feedback loop between ESA and the science community. I think there are some great processes already in place, but as you already said, it can be improved still. Yeah. I'm one of the people who has been around for a long time, as you know. I've already been there when in 2012 the lunar lander looked like it looked like in 2012, and now we have Argonaut, which is great, and we are all very happy that we have the prospect of having scientific instruments and even small missions maybe transported by that lander. You have involved the science community previously. You have asked for mission ideas. You have asked for payload ideas. What is a little bit unclear to many of us is, as you already said, how these results that some of the teams they have created are being utilized beyond sizing the lander. and how they will feed into the program in the future. Like you mentioned, that there will be some opportunities in the next year. Are these going to be completely new teams? Are they going to reinvent the wheel, or are they going to be based on what has happened before? Because some of that has overlapped with teams that have worked on these topics before.
Yeah.
So how is that going to be managed?
Yeah. So I was waiting for that. I also don't have a great answer for you. You're right. So I think in the last program period, we were preparing Argonaut, and there were big plans for how we were going to use Argonaut. The plan was to have multiple e-submissions on this Argonaut, and by the way, the work that we went out with the call to the community, we came back with, here are some mission concepts, here are some payload concepts, and we invested a lot of time and effort in developing those concepts. And I think we got some really fantastic work out of that. And that work is being used all the time. Like in terms of any time somebody goes, oh, what are you going to do with this? Well, stop there. We've done that. So we don't need to ask the community again. One of the things we've also said is for a lot of these ideas, we don't need to talk to the science community because they've told us what they think. Work with that. And when we think we're ready, because we've really got something that we know programmatically, politically, financially, we're really serious about doing, let's go back to the science community. For example, when we talk about Astrolabe, like the work there was work done like on an environment package. When we talk about the prospecting rover, that's coming now, right? The work that was done to say, well, what would a prospecting rover look like? That's the basis for starting to think about that. And I think that we have I think what we have now that is extremely helpful, that you've helped us to create, is a portfolio of everything you want to know about what lunar exploration is going to be with the facilities that we like to have access to. And I think that's really helpful for us. And I think we can use that as the basis to start to understand and scope out what this looks like before we come back to the science community and ask for further inputs. But I think that the program did not evolve, I think, as we had hoped in terms of the scope of what those missions would look like and the way that we'd be able to use Argonaut, for example. So, and I think that one thing we haven't done well, perhaps need to do, is to close out some of those activities, or where they're still open, to see whether there is benefit in continuing some of those things and how we might rescope them. And one of the reasons we haven't done that, honestly, is just because just having the time, the human time to invest in closing out some of those things and make sure we do that in a constructive way. But that's something, an action that certainly is on us that we need to follow up with the different teams and make sure we do this in a proper way.
And also, James, right at the start, you said that we need to be unique. You need to be doing some things that are not copycat, etc. And given that the lunar landscape around the world is changing so rapidly, that portfolio of white papers or ideas that you have might also need reviewing and refreshing maybe every 3 or 4 years, something like that, to make sure that those science questions are still pertinent? Are they still, worth considering? So,
yeah, absolutely. So I think that, and you can tell me if this is wrong, but I think that what we need right now, I think I would be reluctant on the basis we're done to open up a big dialogue or a big consultation about the things that we have here that are really early in their formulation, because I think that we have enough from the work that's been done already to get these things going. And I think when we're really clear about what the questions are we want to ask and how we're going to deal with the input we get from the community, that would be the time to come back and in a very clear way ask for clear inputs from the scientific community. And I would expect that to happen in the next months.
Yeah, maybe we can pause on that thought, but I think you would welcome and your team would welcome some input on this, so we don't have to do it now. But while we mingle here this evening, if people have additional thoughts and they want to input into that process, they can share their thoughts with your team.
Absolutely.
Right. You can take it with you, but thank you once more. I think we should do it more of this at future ELSs, or,
Very good. I hope that was helpful. It was quite long, longer than I thought it was going to be. But I thought it was helpful, and please come and talk to me or any of the other ESA team that are here if you have thoughts or feedback on any of this or any of what I've talked about.
It's only
Thank you.
after 5:30. We are supposed to be here until at least 8 o'clock, so. No, just joking. But anyway, let's give James and his team a round of applause, please.